Heathkit GR-81 3-valve regenerative receiver. This kit was available from about 1961 to 1971. It's a fairly minimalist but functional design. It's a 4-band set. So we've got a band switch here, just designated A, B, C and D. Band A is 150 to 550 kilocycles. Band B is the broadcast band, which is 550 to 1700. Band C is 1700 to 5.5 megs, and then band D is 5.5 megs up to 18 megs. So there's also obviously a regeneration control, volume control, headphone socket, and the headphone socket and the dial lamp are quite an interesting feature of this set, which I'll talk about when we get to the circuit. And there's also fine tuning control. Now when I got the set, the dial pointer was missing from the tuning knob, so I've recreated that with a piece of Perspex and attached that to the knob. It's an odd thing that the original was missing, because it would have only suited this particular type of knob. And one of the aluminium inserts from one of these knobs was missing, so I've recreated that. Punched out a piece of aluminium and cut a slot into it. I'll let you guess which one it was. Now the tuning, you would think it's vernier, but it isn't. It's almost a 2-to-1 ratio. So the pointer moves with the knob. It's geared down. You might be able to see in there. Just a very simple gearing arrangement. So as a result of that, the fine-tuning control is a very welcome and perhaps necessary feature. But again, it's a set which was made for a cost, and they've done pretty well for it. Looking on the top of the chassis, we've got, just move this a bit closer, power transformer. Now despite the set using series feeder valves, it is isolated from the mains. And we've got a filter choke, which is an interesting feature for a low cost set. And the speaker transformer, dual gain tuning condenser, regenerative detector, and first audio output valve, and rectifier and electrolytic condenser for the filtering, and just a very simple oval speaker there. So I'll have a look at the circuit now and just have a run through that. Now to the circuit. And being a regenerative receiver, the heart of the whole thing is this grid leak detector, which is half a 12AT7. Since it's 4-band, there are 4 different coils, A, B, C and D, and each has a primary winding for the aerial, a secondary winding for the grid, and the third winding, of course, is the feedback winding for the positive feedback and regeneration. So there's 2 aerial terminals designated long antenna and short antenna. The long antenna is your conventional long wire aerial, typically 30 meters long, and that goes to either of the primaries through the 4-position rotary switch. And similarly, the secondary windings are selected by another pole on the same switch to feed the grid leak detector, which is a 75 picofarad or microfarad capacitor and 680k grid leak resistor. There's an interesting typo on the circuit regarding the grid leak capacitor. They've only got one U there. It should be 2 U's, so microfarad rather than microfarad. And the short antenna goes to the grid leak detector directly through a 12 microfarad capacitor. Again, they've left out one of the U's, or mu to be pedantic, and that gives a tighter coupling into the detector circuit when you're using a short aerial, only a few meters long. So the theory goes, but I'll talk about that later on when we get to the receiver performance. And finally, of course, the feedback windings on each of the coils. They're in the plate circuit, so high tension comes in through one of the 4 coils and through the coil and back to the plate, so we can get the positive feedback. The regeneration control is adjusted with this 100k pot to vary the high tension of the detector circuit, and that is a far better method than the usual where there's a variable capacitor to vary the current through the feedback windings. The problem with that method is there's terrible backlash and it's very difficult to adjust. Now, as you saw before, there's a dual gang tuning condenser, and the reason for that is that on band A, which is the 150 to 550 kilocycle coil, so that they don't have a huge coil, what they've done is simply connected both gangs in parallel for that. So instead of 400 picofarads, there might be 800. So that's how they get the low frequency band. In the plate circuit is this 1.1 millihenry choke to decouple RF. In reality, it's probably not going to do very much because virtually all of the RF is going to be bypassed by that 0.003 condenser there. So that's all conventional. The audio from the regenerative detector passes through this 0.001 condenser into the second 12AT7 triode. Now that's a very low value for audio, so not surprisingly there's going to be a bit of an absence of low frequency response there. And now why they've done that I don't know. In a lot of circuits they use a low value condenser there to reduce mains hum. The second triode is conventional circuit, 100k plate resistor, 270 ohm cathode resistor for the bias. It's not bypassed, and I presume that is to keep the stage stable with the small amount of negative feedback there. So from the plate into the 50C5 output valve via 0.01 condenser and a 1 meg volume control. They have a normal cathode bias circuit, 220 ohm resistor bypassed with a 20 microfarad condenser, so all very standard. I think they could have used a lower value of volume control, maybe, well, 500k would be better, simply because a 50C5 is going to be prone to grid emission because of its very high heater power, about 7.5 watts. And there is a possibility of the grid going slightly positive with a high value of grid resistor. The power supply is conventional with a 35W4 half-wave rectifier, and that feeds an LC filter. I mean, for a low-cost set, it's interesting that they've used a choke, mostly sets like this would use a resistor about 1k, 2k, and it's filtered with two 50 microfarad electrolytic condensers. Now, as I mentioned before, the dial lamp or the pilot lamp is a bit strange in this set. It's running on the B+, so the lamp doesn't light up until the valves have warmed up. So that can give you an illusion that there's something wrong with the set when you first switch it on. So I don't know why they did that when they could have run it from the AC input. And as is typical with Heathkit, even though it's got series heater valves, they have provided a one-to-one isolation transformer, which is a good thing because for inexperienced constructors and also having a metal chassis, it's a good thing to have the set isolated. So that's just a one-to-one, so 120 volt to 120 volt, or 115 if you prefer. And the 43 ohm resistor there takes place of the usual incandescent 150 milliamp number 47 dial lamp, which goes between pins 4 and 6 on the heater of the 35W4, because that's got a tapped heater specifically for dial lamp use. And the valves are wired in series with a 175 ohm dropper resistor, so that the voltages add up to 120 volts or thereabouts. The other peculiar thing I mentioned, the headphone socket. If you look closely at this, you can see that the speaker is always in circuit. So when the headphones are not plugged in, the contacts there short circuit the phone socket and the speaker works normally, and when you plug the phones in, they're actually still in series with the speaker, so the speaker's never actually cut off. And that means if you're using low impedance phones, say 832 ohms, some sound is still going to come out of the speaker, whereas if you're using 1000 ohm phones, there will be a lot less. So that's the basic rundown of it, and we'll have a look at underneath the chassis. Okay, under the chassis, here we have the 4 coils, so A, B, C and D. There's the 1.1 millihenry plate decoupling choke, the fine tuning condenser, the rotary switch, that's the 35W4, the 50C5, the electrolytic condenser, and in there is the 12AT7. And note that the mains fuse is actually soldered in, and there's the aerial terminals. And if we have a look on the back, I'll just tilt this up. There's the 3 terminals there, the Heathkit label with serial number and model number, and the mains input 105 to 125 volt 50-60 cycle, 30 watts, and 3/4 amp fuse. So that's the back of the set, and we'll have a run through the performance next. Obviously, since the main supply here is 240 volts and the set runs on 120, I have here my UTC 44 step down transformer, which is rated at 250 watts. So this is an auto transformer, so it's not actually isolated, but I'm happy to use it with the Heathkit because the Heathkit has its own isolating transformer. I wouldn't advise the use of this kind of step-down transformer. For a live chassis set, you should use a double wound transformer. So with that, let us now power it up. I've set the band to the broadcast, and I've got the aerial on the long aerial connection, so let's power it up and see what happens. Now, we'll just wait for this to warm up. I don't know if you'll be able to see the dial lamp come up because it's a very faint neon bulb. Oh yeah, here it comes. So with the regeneration wound up, now that's with the volume full up, so it's pretty weak. And now this station, or all these stations I'll be tuning through, are located about 57 kilometres away, 5 kilowatt commercial stations in Sydney. So it's pretty yeah, lackluster, if you like. Yeah, very weak. Now the 50 kilowatt ABC station should be a bit stronger.
SMS number 0467920222. Alright, the Aussies resuming at 1 for 112. The story of the morning has been Sam Costas making 60.
A lot better, but still that's with the volume full blast.
We get ready for some cricket.
Now, I'll go over to the short connection.
What a bizarre, outrageous
difference.
day of Test cricket they've seen so far with young Constance. Back there in the Middle Ages. Traditions that followed were mostly rooted in religion, but in modern times it's largely moved away from that. I'd love to dig this one out, so let's find out why we call it Boxing Day.
Now this station here is 2LT, which is 60 kilometres to the west of me, and it's directed away, but it's coming in, you know, quite well for a regenerative receiver. So it seems to me that the long wire connection is something you wouldn't normally use. The coupling is just so poor, it's impractical to use. So it's a lot better with the short connection.
954 AM on stereo DAB. This is easy music to UE.
Less than 60 seconds.
It's the best time in racing.
There's a bit of interference from my solar regulator.
This extraordinary city of Darwin into
Shane Watson, Steve Smith, Stuart Collins,
And the Rue Bossière.
There's not much up the end of the band.
About to be launched at Richmond. We are hosting today's broadcast from the lands of the
We still get a Christmas bonus, which I think there probably aren't that many
anymore. But
So we'll have a look at the low end of the band, well the low band I should say. There's virtually nothing here except for a couple of airport beacons. See if I can get one. So for continuous wave signals you leave the detector oscillating slightly. So yeah, not much on the long wave band here. And because it's daylight hours, we're probably not going to get anything on the shortwave. Well, not much, maybe a couple of Chinese high-powered stations. I think all these heterodynes must be harmonics from my solar charger, because they're spaced evenly across the band. But yeah, not much to listen to, I'm afraid. So that's the daytime performance, and I'll give a demonstration for the nighttime performance. Right, just before I do the nighttime demonstration, I'll just talk about the terrible sensitivity with the long aerial connection. It seems to me the cause of that is the distance between the primary and secondary coils is actually a lot greater than it normally would be. Every other designer, well most other designs I've looked at and have used, the distance is about 3 millimeters between the two, but here we've probably got about 8 millimeters, so I'd say that's why it is, and I really can't see the set ever providing, you know, good performance with that connection. But having said that, at least on the short connection, it does actually give the degree of coupling that I would hope for, and it works a lot better that way. So with that out of the way, we'll get on to the nighttime demonstration. Alright, it's 9:46 in the evening. Let's see what we can tune in. This is still on medium wave.
Being followed by the
저희가 자연 속에서 어떠한 위치에 있는지
Fantastic bowler. He's made a move to Tasmania.
Mother's Day. Put that information more in so if somebody contacts that.
They're not-for-profit marine conservation.
one flat to half.
Okay, we'll try band C. Single sideband on the 3.5 meg diameter band. Probably won't be much at the lower frequencies down around the marine band. This is a single sideband marine beacon. Tried band D, which is sort of the main shortwave band, 6 to 18 megs, is where all this stuff happens. Well, not a lot down there. Sideband in the 7 meter band, 7 megahertz band I should say. Yeah, so it can receive amateur transmissions. Something that's actually Chinese.
foster connections with people's history and culture.
So there you go, the GR-81 4-band shortwave receiver.